Appendix 4 of Edison, His Life and Inventions. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Heidi Preuss. Edison, His Life and Inventions by Frank Louis Dyer and Thomas Comerford Martin. Appendix 4. Wireless Telegraphy. Although Mr. Edison has taken no active part in the development of the more modern wireless telegraphy, and his name has not occurred in connection therewith, the underlying phenomena had been noted by him many years in advance of the art, as will presently be explained. The authors believe that this explanation will reveal a status of Edison in relation to the subject that has thus far been unknown to the public. While the term wireless telegraphy, as now applied to the modern method of electrical communication between distant points without intervening conductors, is self-explanatory, it is also applicable, strictly speaking, to the previous art of telegraphing to and from moving trains, and between points not greatly remote from each other and not connected together with wires. The latter system, described in Chapter 23, and in a succeeding article of this appendix, was based upon the phenomena of electric-magnetic or electrostatic induction between conductors separated by more or less space, whereby electric impulses of relatively low potential and low frequency set up in one conductor were committed inductively across the air to another conductor, and there received through the medium of appropriate instruments connected therewith. As distinguished from this system, however, modern wireless telegraphy, so-called, has basis in the utilization of electric or ether waves in free space, such waves being set up by electric oscillations or surgings of comparatively high potential and high frequency, produced by the operation of suitable electrical apparatus. Broadly speaking, these oscillations arise from disruptive discharges of an inductive coil, or other form of oscillator, across an air gap, and their character is controlled by the manipulation of a special type of circuit-breaking key, by means of which long and short discharges are produced. The electric or etheric waves thereby set up are detected and received by another special form of apparatus, more or less distant, without any intervening wires or conductors. In November 1875, Edison, while experimenting in his Newark laboratory, discovered a new manifestation of electricity through mysterious sparks which could be produced under conditions unknown up to that time. Recognizing at once the absolutely unique character of the phenomena, he continued his investigations enthusiastically over 2 months, finally arriving at a correct conclusion as to the oscillatory nature of the hitherto unknown manifestations. Strange to say, however, the true impact and practical applicability of these phenomena did not occur to his mind. Indeed, it was not until more than 12 years afterwards, in 1887, upon the publication of the notable work of Professor H. Hertz, proving the existence of electric waves in free space, that Edison realized the fact that the fundamental principle of aerial telegraphy had been within his grasp in the winter of 1875. For although the work of Hertz was more profound and mathematical than that of Edison, the principle involved and the phenomena observed were practically identical. In fact, it may be remarked that some of the methods and experimental apparatus were quite similar, especially the dark box with micrometer adjustment used by both in observing the spark. Footnote 25. 25. During the period in which Edison exhibited his lightning system at the Paris Exposition in 1881, his representative, Mr. Charles Batchelor, repeated Edison's remarkable experiments of the winter of 1875 for the benefit of a great number of European savants, using with other apparatus the original dark box with micrometer adjustment. There is not the slightest intention on the part of the authors to detract in the least degree from the brilliant work of Hertz. On the contrary, to ascribe to him the honor that is his due in having given mathematical direction and certainty to so important a discovery. The adaptation of the principles thus elucidated, and the subsequent development of the present wonderful art by Marconi, Branly, Lodge, Slaby, and others, are now too well known to call for further remark at this place. Strange to say, that although Edison's early experiments in etheric force called forth extensive comment and discussion in the public prints of the period, they seem to have been generally overlooked when the work of Hertz was published. At a meeting of the Institution of Electrical Engineers, held in London on May 16, 1889, at which there was a discussion on the celebrated paper of Professor Sir Oliver Lodge on lightning conductors. However, the chairman, Sir William Thomson, Lord Kelvin, made the following remark: "We all know how Faraday made himself a cage 6 feet in diameter, hung it up in mid-air in the theatre of the Royal Institution, went into it, and, as he said, lived in it and made experiments. It was a cage with tinfoil hanging all around it. It was not a complete metallic enclosing shell. Faraday had a powerful machine working in the neighborhood, giving all varieties of gradual working up and discharges by impulsive rush, and whether it was a sudden discharge of ordinary insulated conductors, or of Leyden jars in the neighborhood outside the cage, or electrification and discharge of the cage itself, he saw no effect on his most delicate gold-leaf electroscopes in the interior. His attention was not directed to look for Hertz sparks, or probably he might have found them in the interior. Edison seems to have noticed something of the kind in what he called the etheric force. His name etheric may 13 years ago have seemed to many people absurd, but now we are all beginning to call these inductive phenomena etheric. With these preliminary observations, let us now glance briefly at Edison's laboratory experiments, of which mention has been made. On the first manifestation of the unusual phenomena in November 1875, Edison's keenness of perception led him at once to believe that he had discovered a new force. Indeed, the earliest entry of this discovery in the laboratory notebook bore that caption. After a few days of further experiment and observation, however, he changed it to etheric force, and the further records thereof, all in Mr. Bachelor's handwriting, were under that heading. The publication of Edison's discovery created considerable attention at the time, calling forth a storm of general ridicule and incredulity. But a few scientific men of the period, whose experimental methods were careful and exact, corroborated his deductions after obtaining similar phenomena by repeating his experiments with intelligent precision. Among these was the late Dr. George M. Beard, a noted physicist, who entered enthusiastically into the investigation and, in addition to a great deal of independent experiment, spent much time with Edison at his laboratory. Dr. Beard wrote a treatise of some length on the subject, in which he concurred with Edison's deduction that the phenomena were the manifestation of oscillations, or rapidly reversing waves of electricity, which did not respond to the usual tests. Edison had observed the tendency of this force to diffuse itself in various directions through the air and through matter, hence the name etheric that he had provisionally applied to it. Edison's laboratory notes on this striking investigation are fascinating and voluminous, but cannot be reproduced in full for lack of space. In view of the latter practical application of the principles involved, however, the reader will probably be interested in perusing the few extracts therefrom, as illustrated by facsimiles of the original sketches from the laboratory notebook. As the full significance of the experiments shown by these extracts may not be apparent to a lay reader, it may be stated by way of premise that ordinarily a current only follows a closed circuit. An electric bell or electric light is a familiar instance of this rule. There is in each case an open wire circuit which is closed by pressing the button or turning the switch, thus making a complete and uninterrupted path in which the current may travel and do its work. Until the time of Edison's investigations of 1875, now under consideration, electricity had never been known to manifest itself except through a closed circuit. But as the reader will see from the following excerpts, Edison discovered a hitherto unknown phenomenon, namely, that under certain conditions the rule would be reversed and electricity would pass through space and through matter entirely unconnected with its point of origin. In other words, he had found the forerunner of wireless telegraphy. Had he then realized the full import of his discovery, all he needed was to increase the strength of the waves and to provide a very sensitive detector like the coherer in order to have anticipated the principal developments that came many years afterwards. With these explanatory observations, we will now turn to the excerpts referred to, which are as follows. November 22, 1875. New force. In experimenting with a vibrator magnet, consisting of a bar of stub steel, fastened at one end and made to vibrate by means of a magnet, we noticed a spark coming from the cores of the magnet. This we have noticed often in relays and stock printers, when there were little iron filings between the armature and core, and more often in our new electric pen, and we have always come to the conclusion that it was caused by strong induction. But when we noticed it on this vibrator, it seemed so strong that it struck us forcibly there might be something more than induction. We now found that if we touched any metallic part of the vibrator or magnet, we got the spark. The larger the body of iron touched to the vibrator, the larger the spark. We now connected a wire to X, the end of the vibrating rod, and we found we could get a spark from it by touching a piece of iron to it. And one of the more curious phenomena is that if you turn the wire around on itself and let the point of the wire touch any other portion of itself, you get a spark. By connecting X to the gas pipe, we drew sparks from the gas pipes in any part of the room by drawing an iron wire over the brass jet of the cock. This is simply wonderful, and a good proof that the cause of the spark is a true unknown force. November 23, 1815. New force. The following very curious result was obtained with it. The vibrator shown in Figure 1 and battery were placed on insulated stands, and a wire connected to X, tried both copper and iron, carried over to the stove about 20 feet distant. When the end of the wire was rubbed on the stove, it gave out splendid sparks. When permanently connected to the stove, sparks could be drawn from the stove by a piece of wire held in the hand. The point X of the vibrator was now connected to the gas pipe, and still sparks could be drawn from the stove. Put a coil of wire over the end of rod X and passed the ends of spool through galvanometer without affecting it in any way. Tried a 6 ohm spool, add a 200 ohm. We now tried all the metals, touching each one in turn to the point X. Here follows a list of metals and the character of sparks obtained with each. By increasing the battery from 8 to 12 cells, we get a spark when the vibrating magnet is shunted with 3 ohms. Cannot taste the least shock at B, yet between carbon points the spark is very vivid. As will be seen, X has no connection with anything. With a glass rod 4 feet long, well rubbed with a piece of silk over a hot stove, with a piece of battery carbon secured to one end, we received vivid sparks into the carbon, when the other end was held in the hand with the handkerchief. Yet the galvanometer, chemical paper, the sense of shock in the tongue, and a gold-leaf electroscope, which would diverge at 2 feet from a half-inch spark-plate glass machine, were not affected in the least by it. A piece of coal held to the wire showed faint sparks. We had a box made thus, whereby 2 points could be brought together within a dark box provided with an eyepiece. The points were iron, and we found the sparks were very irregular. After testing some time, 2 lead pencils found more regular and very much more vivid. We then substituted the graphite points instead of iron. 26. 26. The dark box had micrometer screws for delicate adjustment of the carbon points, and was thereafter largely used in this series of investigations for better study of the spark. When Mr. Edison's experiments were repeated by Mr. Bachelor, who represented him at the Paris Exposition of 1881, the dark box was employed for a similar purpose. After recording a considerable number of other experiments, the laboratory notes go on to state: November 30, 1875. Etheric force. We found the addition of battery to the Stubbs wire vibrator greatly increased the volume of the spark. Several persons could obtain sparks from the gas pipe at once, each spark being equal in volume and brilliancy to the spark drawn by a single person. Edison now grasped the gas pipe, and with the other hand holding a piece of metal, he touched several other metallic substances, obtained sparks, showing that the force passed through his body. December 3, 1875. Etheric force. Charlie Edison hung to the glass pipe with feet above the floor, and with a knife got sparks from the pipe he was hanging on. We now took the wire from the vibrator in one hand, and stood on a block of paraffin 18 inches square and 6 inches thick. Holding a knife in the other hand, we drew sparks from the stovepipe. We now tried the crucial test of passing the etheric current through the sciatic nerve of a frog just killed. Previous to trying, we tested its sensibility by current from a single Bunsen cell. We put in resistance up to 500,000 ohms, and the twitching was still perceptible. We tried the induced current from our induction coil, having one cell on primary, the spark jumping about 1/50th of an inch, the terminal of the secondary connected to the frog, and it straightened out in violence. We arranged frogs' legs to pass etheric force through. We placed legs on an inverted beaker, and held the 2 ends of the wire on glass rods 8 inches long. On connecting one to the sciatic nerve, and the other to the fleshy part of the leg, no movement could be discerned, although brilliant sparks could be obtained on the graphite points when the frog was in current. Dr. Beard was present when this was tried. December 5, 1875. Etheric force. 3 persons grasping hands and standing upon blocks of paraffin 12 inches square and 6 thick drew sparks from the adjoining stove, when another person touched the sounder with any piece of metal. A galvanoscopic frog giving contractions with one cell through the water rheostats was placed in circuit. When the wires from the vibrator and the gas pipe were connected, slight contractions were noticed, sometimes very plain and marked, showing the apparent presence of electricity, which from the high insulation seemed improbable. Dr. Beard, who was present, inferred from the way the leg contracted that it moved on both opening and closing the circuit. To test this, we disconnected the wire between the frog and the battery, and placed instead of a vibrating sounder a simple Morse key and a sounder taking the etheric from armature. The spark was now tested in dark box and found to be very strong. It was then connected to the nerves of the frog, but no movement of any kind could be detected upon working the key, although the brilliancy and power of the spark were undiminished. The thought then occurred to Edison that the movement of the frog was due to mechanical vibrations from the vibrator, which gives probably 250 vibrations per second, passing through the wires and irritating the sensitive nerves of the frog. Upon disconnecting the battery wires and holding a tuning fork giving 326 vibrations per second to the base of the sounder, the vibrations over the wire made the frog contract nearly every time. The contraction of the frog's legs may be with considerable safety be said to be caused by these mechanical vibrations being transmitted through the conducting wires. Edison thought that the longitudinal vibrations caused by the sounder produced a more marked effect, and proceeded to try out his theory. The very next entry in the laboratory notebook bears the same date as the above, December 5, 1875, and is entitled Longitudinal Vibrations, and reads as follows. We took a long iron wire 1/16 of an inch in diameter, and rubbed it lengthways with a piece of leather with resin on for about 3 feet, backwards and forwards. About 10 feet away we applied the wire to the back of the neck, and it gives a horrible sensation, showing the vibrations are conducted through the wire. The following experiment illustrates notably the movement of the electric waves through free space. December 26, 1875. Etheric force. An experiment tried tonight gives a curious result. A is a vibrator, B, C, D, and E are sheets of tinfoil hung on insulating strands. The sheets are about 12 by 8 inches. B and C are 26 inches apart, C and D 48 inches, and D and E 26 inches. B is connected to the vibrator and E to point in dark box, the other point to ground. We received sparks at intervals although insulated by such space. With the above, our extracts must close, although we have given but a few of the interesting experiments tried at the time. It will be noticed, however, that these records show such progression in little over a month. Just after the item last above extracted, the Edison shop became greatly rushed on telegraphic inventions, and not many months afterwards came the removal to Menlo Park. Hence the etheric force investigations were sidetracked for other matters deemed to be more important at that time. Dr. Beard, in his previously mentioned treatise, refers on page 27 to the views of others who have repeated Edison's experiments and observed the phenomena, and in a footnote says, Professor Houston, of Philadelphia, among others, has repeated some of these physical experiments, and has adopted in full, and after but a partial study of the subject, the hypothesis of rapidly reversed electricity, as suggested in my letter to the Tribune of December 8th, and further claims priority of discovery, because he observed the spark of this when experimenting with a Ruhmkorff coil 4 years ago. To this claim, if it be seriously entertained, the obvious reply is that thousands of persons probably had seen this spark before it was discovered by Mr. Edison. It had been seen by Professor Neeffer, who supposed, and still supposes, it is the spark of the extra current. It has been seen by my friend Professor J. E. Smith, who assumed, as he tells me, without examination, that it was inductive electricity breaking through bad insulation. It had been seen, as has been stated, by Mr. Edison many times before he thought it was worthy of study. It was undoubtedly seen by Professor Houston, who, like so many others, failed to even suspect its meaning, and thus missed an important discovery. The honor of a scientific discovery belongs not to him who first sees a thing, but to him who first sees it with expert eyes, not to him even who drops an original suggestion, but to him who first makes that suggestion fruitful of results. If to see with the eyes a phenomenon is to discover the law of which that phenomenon is a part, then every schoolboy who before the time of Newton ever saw an apple fall was a discoverer of the law of gravitation. Edison took out only one patent on long-distance telegraphy without wires. While the principle involved therein, induction, was not precisely analogous to the above, or to the present system of wireless telegraphy, it was a step forward in the process of the art. The application was filed May 23, 1885. At the time he was working on induction telegraphy, 2 years before the publication of the work of Hertz. But the patent, number 465971, was not issued until December 29, 1891. In 1903 it was purchased from him by Marconi Wireless Telegraph Company. Edison has always had a great admiration for Marconi and his work, and a warm friendship exists between the two men. During the formative period of the Marconi Company, attempts were made to influence Edison to sell this patent to an opposing concern. But his regard for Marconi and belief in the fundamental nature of his work were so strong that he refused flatly, because in the hands of an enemy the patent might be used inimically to Marconi's interests. Edison's ideas, as expressed in the specification of this patent, show very clearly the close analogy of his system to that now in vogue. As they were filed in the Patent Office several years before the possibility of wireless telegraphy was suspected, it will undoubtedly be of interest to give the following extract therefrom. I have discovered that if sufficient elevation be obtained to overcome the curvature of the earth's surface, and to reduce to the minimum the earth's absorption, electric telegraphing or signaling between distant points can be carried on by induction without the use of wires connecting such distant points. This discovery is especially applicable to telegraphing across bodies of water, thus avoiding the use of submarine cables, or for communicating between vessels at sea, or between vessels at sea and points of land. But it is also applicable to electric communication between distant points on land, it being necessary, however, on land, with the exception of communication over open prairie, to increase the elevation in order to reduce the minimum the induction absorbing effect of houses, trees, and elevations in the land itself. At sea, from an elevation of 100 feet, I can communicate electrically at great distance, and since this elevation, or one sufficiently high, can be had by utilizing the masts of ships, signals can be sent and received between ships separated a considerable distance, and by repeating the signals from ship to ship, communication can be established between points at any distance apart or across the largest seas and even oceans. The collision of ships in fog can be prevented by this character of signaling, by the use of which also the safety of a ship in approaching a dangerous coast in foggy weather can be assured. In communicating between points on land, poles of great height can be used, or captive balloons. At these elevated points, whether upon the masts of ships, upon poles or balloons, condensing surfaces of metal or other conductor of electricity are located. Each condensing surface is connected with earth by an electrical conducting wire. On land this earth connection would be one of usual character in telegraphy. At sea the wire would run to one or more metal plates on the bottom of the vessel, where the earth connection would be made with the water. The high-resistance secondary circuit of an induction coil is located in circuit between the condensing surface and the ground. The primary circuit of the induction coil includes a battery and a device for transmitting signals, which may be a revolving circuit breaker operated continually by a motor of any suitable kind, either electrical or mechanical, and a key, normally short-circuiting the circuit breaker or secondary coil. For receiving signals, I locate in said circuit, between the condensing surface and the ground, a diaphragm sounder, which is preferably one of my electromotograph telephone receivers. The key normally short-circuiting the revolving circuit breaker, no impulses are produced in the induction coil until the key is depressed. When a large number of impulses are produced in the primary, and by means of the secondary corresponding impulses or variations in tension are produced at the elevated condensing surface, producing thereat electrostatic impulses. These electrostatic impulses are transmitted inductively to the elevated condensing surface at the distant point, and are made audible by the electromotograph connected to the ground circuit with such distant condensing surface. The accompanying illustrations are reduced facsimiles of the drawings attached to the above patent, number 465971. End of Appendix 4.